excited to dig into inference. You have an exceptional panel over here. Everyone comes from a different walk of life, and love to go around and everyone to introduce themselves, and then we can dig into the first question. Yusuf, you want to start?
Yeah, thank you. My name is Yusuf. So I have, until 2 months ago, I have been leading Snowflake's Cortex apps, their talk to your data product portfolio. 2 months ago, I left to start a new company working in the intersection between media generation, reasoning, and creative tasks. Yeah.
Hello. My name is Ville, CEO, co-founder at Outerbounds, where we create a developer platform for standout AI products. It's based on an open source project called Metaflow that we studied at Netflix. So many of us have a background at Netflix, so that's where we come from.
Yeah. Hey everyone, I'm Nikitha. I lead the Inference product at Together AI, which is an AI native cloud. We mainly host open source models. We also do a bit of training and post-training. Previously, I was at Temporal, also DevTools infrastructure. Prior to that, Google and VMware.
Right. So I think the biggest question at Inference right now is when you think about what the media headlines are, we all hear about smaller models, quantization, context length. But if you really dig into kind of the details, where do you think is kind of the 10x difference in inference breakthrough in terms of cost, latency, quality? And I'm talking about it from 3 different directions. One is algorithmic. So by algorithmic, I mean you think of sparse attention, you think of routing, or is it system level? You think of compilers or kernel fusion and so on, or from context memory approaches. So is it smart retrieval or is it context engineering? So there are 3 or 4 different paradigms, and maybe there are 4, maybe there are 3, maybe I'm mixing 2. Help clarify. So maybe I can start with Nikitha.
Yeah, I think I'm a little biased. Obviously, we do inference and we like to do it really well at Together. And something we've invested a lot in is custom speculators. And given that inference, even though the models are getting cheaper to train, as the models get bigger, the cost of inference is also growing, especially when you get these huge parameter size models. And so I think training a custom speculator has actually proven to be really effective, especially as we see more of a customer's inference traffic, we can actually do much better than a base speculator. So it's custom trained on that specific traffic. And we've noticed up to, it's up to 50% cheaper, 2 to 3 times faster. So there's a lot of room for improvement, both on the cost side and just general speed of inference that you can get from really good spec decoding techniques.
Very cool. Ville, I would love to get your take more from a developer velocity point of view. How do you agree with Nikitha? Do you think it's a different layer compared to what she mentioned?
First I have to thank Together AI and everybody else doing all those optimizations. I absolutely think that that's something that's absolutely necessary, that we need all those algorithmic improvements and all that stuff. And I think that work will continue for many years to come. I guess our biased point of view is coming from the fact that we support very diverse workloads, kind of many different kinds of things. I guess you're working on multimodal kind of a media generation, as well as LLMs, also a very specific tasks. And I think what we are seeing is that as AI is expanding, I don't think that there will be one size fits all approach to anything. I mean, sometimes you want small models, sometimes you want absolutely the largest reasoning model. And hence, I'm a big believer in maybe more a routing approach, where you can choose the right tool for the job. And then since you asked about the 10x is a lot. And I think that the main thing there is to kind of really make sure that you are at times not using oversized models, at times when you need it, you have all the capacity, all the optimizations for the largest models. But I think that it kind of feels that almost inevitably, I mean, there will be so many different use cases that we need different approaches for different workloads.
We've touched algorithmic, we've touched systemic level. How about context and memory approaches? Let's dig into that piece as well a little bit, and I'm wondering will better length would let a better quality, would better orchestration, what would really change the dynamics for having better context in inference? Yusuf, would love to get your thoughts.
What I would mention there is, I think the beginning of this year, we were all waiting for the step function jump to the GPT-5 moment or something along those lines. I think that happened a bit earlier than the actual model launch with Cloud Code. Turns out if you optimize a system for using tools like planning memory and file access, it can actually do wonders in how it utilizes context. So I think that showed that there is still low-hanging fruit for better utilizing context, better retrieval, smarter retrieval, and it essentially, not only the product itself, but in terms of the approach, I think opened the door for a lot of interesting things. I would take a 2xing, 10xing of context window as well, but I would say there is a lot of work to be done when it comes to using the context smarter.
And if I were to specifically break that down into like improving context, how would you improve context? Would you improve it through better orchestration? Would you improve it through like better tool calling? Like what are you thinking in that direction?
Essentially, I would see most of the utility in calling the right tools in the right way and efficiently. I would essentially look at how many tool calls does it take to get to the right answer, and use the LLM for finding that trajectory that leads to the right tool calls and combining them correctly for the answer.
Curious, like what kind of, maybe it's a question for Nikitha, like what kind of tools are you seeing as kind of the next generation of tools that can be like effectively used to improve tool calling?
Yeah, I think tool calling, the proprietary models, OpenAI, Anthropic, have gotten really good at them.
Yeah.
I think the challenge still remains, while the models themselves, especially the open source models, have good tool calling functionality baked in, a lot of that actual implementation comes down to the inference providers. So you'll see like a huge degree of variance across providers when it comes to tool calling. And that's something I think all of us sort of need to get better at. It's a very challenging problem. I think for me, at least at Together, one of our priorities is going to be building a lot of those native tool calling functions that already exist, like web search, and having that be built natively into our inference platforms as well. I think, yeah, so with the context size expanding, I think garbage in, garbage out is kind of what I'm seeing. So just using, there's a bunch of tools we already have. I think just using those really effectively can get you a long way.
Makes sense. Ville, what do you see are the next few tools that will be in usage going forward?
Yeah, I think it's kind of interesting that in the early days, like a couple of years back, everybody was fighting kind of against like a really small context windows, and then like there was this amazing kind of a growth in the context window size, and already now I'm like, what are we like at the million or like a 4 million tokens, something like that. And of course, like one can asymptotically think that, okay, like kind of what if like the context windows are like nearly infinite? And I think it's becoming clear that there is not the world like where you can just expect to dump everything, to your point about the garbage in and garbage out. But even if you had like kind of all the relevant context in the context window, I don't think there's a reasonable expectation that the LLMs are able to kind of like find all the right needles in the haystack, especially like in a real world applications. And also then, of course, there's the performance question as well, that it turns out to be incredibly expensive. So I think it will be all of the above. I think that the kind of the 2023 style RAG is most likely not going to be enough. I think there will be memory systems, like we will have different like agentic approaches, definitely like a tool calling of different sort. Of course, the tool calling by itself, I mean, needs to evolve, and what kind of like output we get from tools and so forth. But yeah, I think that that's like the whole like a question of context engineering. Of course, is even like from our point of like one of the key levers, like how you build something differentiated. So I think that that's how companies can differentiate themselves. That like you really get good at like deciding what goes in the context. So.
Yusuf, do you want to add anything to it?
I would mention that the frontier labs usually kind of guide the ecosystem or dictate by way of choosing the first-party tools that will be used more and more effectively. I think, as Nikitha mentioned, O3 brought in web search, for example, and with Cloud Code, you see more planning and memory coming into foray. I think there is a rise in browser use as a tool, with a lot of agentic browser conversations, with browser wars coming into the nomenclature again. Yeah, those would be the ones that I would mention.
Do you see this as a separate operating system being built out, as like a context engineering RAG workflow, which is like net new, versus do you see this as a part of being subsumed in the model ecosystem as the models become better, as the AI labs think about solving this problem as well? Nikitha, you want to take that?
It's a good question. If I had to venture a guess, I would say there's a really healthy ecosystem being built around the models themselves. And potentially that's where it continues. Just because a lot of this stuff is, obviously the tool calling is not necessarily always deterministic, but what's happening in the tools themselves usually is. And so that's usually like fits into the paradigm that we already have. But I don't know, curious to hear your thoughts, Ville.
No, I think it's like I'm sure that like there are many people in the audience like building your own applications and services and products, and the question is that like where does the differentiation happen? And yes, I mean I fully agree that of course the frontier labs are like kind of really like raising the kind of the baseline for everybody. So that's the kind of almost like a low bar, because like you kind of whatever you are building, I mean it has to be better than like just what you can get by going to ChatGPT. And then like where the differentiation oftentimes happens is exactly like kind of what goes in the context, what kind of tools you use, how do you use them, and like the whole like application layer, not to, of course, like forgetting the whole like user experience on top of that. So yeah, I'm actually like, I think like we are in super early days when it comes to that.
We've been talking a lot about like cost of inference. Let's quantify that a bit. Like when you think of the metrics around this, there's this metric around $ per 1,000 tokens, which is always thrown out, but seems like a vanity metric. What would you think is kind of the right metric if you were to pick like cost per query or throughput per watt or like effective latency? Like which one would you pick? And maybe let's start from the other side.
I mean, I have started talking about tool calling. I'll continue from there, mostly because I feel like a lot of the differentiation, as you mentioned, comes through the specific tools that an application is calling. So looking at a successful answer and then looking at the cost of that answer and materializing how many effective tool calls contributed to that answer, I think actually gives a very good measure of how effective the LLM was in producing value. Here I would distinguish between many tool calls versus the tool calls that actually contributed. You know, you then avoid things like searching a lot just for the sake of searching, but look at tool calls or searches, for example, that actually contribute to the final answer, assuming that the final answer was right.
Could you quantify that? What would that be?
I think that you can essentially look at the cost of the trajectory itself and then divide that by the number of tool calls that actually contributed to the answer.
Got it. Ville, what are your thoughts on that?
Well, I think like I mean, first, I mean, it has been crazy market now, like kind of for the past couple of years. And it seems like today, they're like pretty much like two dominant like business models around inference. And of course, like you can comment more on that. That's what Together.ai does. And one is that like you pay for tokens, right? So you pay for input tokens, output tokens. You're going to have this like a serverless model. And then the other one is that like you basically pay for compute capacity. So you have dedicated instances. You basically like effectively rent GPUs, and then you have your models hosted on those GPUs. So those are the kind of the two ways how you can do it today. And this is pretty much like what you get from any vendor. You can go to AWS Bedrock, you can go to Together, you can go to anybody, and like pretty much everybody provides these two different modalities. It's an interesting question, like how that will evolve. I think to your question, I think it's interesting to think like what else could be there. To your point about the tool calling and the value there. Also, like I think like I'm sure that like kind of there will be companies like pushing the kind of the level of abstraction upwards, and it might be something like a cost per like a task completed. That it's not so much about like, because I mean we are quickly approaching the point where the input tokens and the output tokens are getting kind of meaningless a bit. And also like the renting the GPUs is kind of a bit low level as well. But I mean more so that, okay, like what is the actual like useful unit of output? And then like even like today, if you think about like OpenAI and how people use, let's say ChatGPT, it's much about like, okay, I want a useful result. I don't have to, I mean, I'm sure that they're using GPUs, but not my problem, right? And even like the input tokens, not my problem and so forth. But I mean, I want to pay for the results. I think that there must be innovation coming on that front.
That's great. So that is output based on what tools you've called. You were like number of tasks performed dollar per task performed. And Nikitha, what are you
I think what I'm going to say will eventually come down to cost per query. But typically when we have really large customers come to us to run inference for them, I think the first thing they want to see is just time to first token, which is how fast can you get this done. Obviously, the more number of GPUs you throw at it, the faster you can get it done. And then it moves on to, okay, now like where on the cost performance curve do we want to be? And so then we push the number of GPUs down until they reach a point where like they see a cost that they're comfortable with for the latency that they're also comfortable with. And so a lot of techniques go into optimizing cost per query on our side, and depending on what the customer wants to do, quantization, batch sizes, if we add a spec decoder. So all of that kind of contributes, but I think the baseline that usually customers are looking for is like, what is the cost per query?
Got it. Makes sense. Switching gears a bit, I'd love to dig into the CUDA ecosystem and like how that's evolving. Like we see NVIDIA like still extracting 80% of the margins. And then you have like custom inference companies out there, like Groks of the world and Cerebras of the world. And the question is that, do you see another CUDA equivalent emerging, or do you see it more like an open ecosystem? And maybe you could start with Ville over here, just to get your point of view on, because you have this point of view from an open source perspective, because of your Metaflow background. So what are you thinking on that?
Well, I think an interesting question, especially like in the context of inference that we are talking about, is that of course CUDA predates inference and like even predates like I guess like all of this AI boom. So I'm pretty sure that like even like let's say hypothetically if CUDA didn't exist today, even NVIDIA wouldn't reinvent CUDA by itself. And I think like where things are trending today, I hope and I do believe that it won't be winner takes all. I think like we need different hardware providers. I think it's only healthy for the ecosystem. On the other hand, I don't necessarily think that like we need like a super long tail. I mean, realistically, I think it's good that like there will be a good handful. And then like when it comes to like the other hardware providers, I really do hope that they don't have to reinvent CUDA. And especially like for like inference use cases, something that is much more like task specific. And then I'm sure that like kind of probably like Coursera.ai and many others are already like working with hardware providers, like really like making sure that the higher level service that the customers want can be provided, like kind of regardless like what is the software stack like underneath. It's of course a more interesting question, I guess, in open source, what that will look like. I think in many ways, like from the community point of view, I think like CUDA is of course like a very dominant. It will be hard to displace that necessarily. But then the interesting question is always that like, does it even matter? But, I mean, for the longest time, there has been this idea that like it is such a moat that that's what makes, let's say, NVIDIA special. I mean, the interesting question is that, well, I mean, maybe the world will like just work around it in different ways.
And how do you think like Metaflow, Ray, other compilers will help in that spectrum?
Yeah, I think it kind of goes back to this idea that I think like a kind of a CUDA is there. It is a dominant force. Like for many things, but it won't be the only game in town. And it's not so much that like we need like I think that there has been always in the past like attempts that, okay, let's have an open version of something like kind of, I guess there was technically even like OpenCL, like competing with that maybe. But I mean, I think more interestingly, it might be that like as we start understanding the different types of use cases, then like we will get solutions and stacks that really work well for those use cases. Then the CUDA becomes more like an implementation detail that really doesn't necessarily matter so much for like many tasks. So.
Love to hear Nikitha's vantage point on this, the hardware, software, co-design loop.
Yeah, I would love to see more diversity, I think, at that layer would be great for the ecosystem, but it's just really, really hard, even with just one. Every chip version, like something breaks, and it is really difficult for everyone involved. So yeah, it's a huge challenge. I think also like the companies making sort of custom inference chips, I think it's really exciting, especially I have a hardware background, so it's really cool to see all the innovation going on there. But I think it really means that these companies have to build a lot of optionality and make sure that at the runtime and compile level, it is still very flexible, just because I think the ecosystem is moving so quickly in a potentially like post-transformer world, or as you start to see more algorithmic changes. If the chip can't adapt, that's going to be really hard. So I think making sure there's that flexibility without having to like refab a chip is going to become really important.
I would love to bring back the question of memory. When we spoke about memory earlier, we didn't touch on persistent memory. And persistent memory is still in prototype phase today. And if you were to think of like from a technical feasibility point of view, that can this become production ready, as well as from an enterprise use case point of view, like who actually needs persistent memory. I'd love to kind of dig into both of those aspects. So maybe Yusuf, if you could like maybe help me think about the enterprise use cases of persistent memory.
I think of memory in the context of application state and sources of truth. And it comes up in the context of that for enterprise quite a bit as well. I think applications that work really use the LLM at the foundation and kind of don't plug that in as an appendage on the side. So I think there is no world in which this works without the LLM being aligned with application state expectations from the user. So when that works well, when the LLM actually, either through smarter context usage, etc., has a clear map of what the application state is, and this is aligned with the end user expectations, it really works well. We see this in coding, but we see this in other applications as well. So, like, to the answer of like, is this niche? I don't think this will stay niche. Like, things that work will require it, but there is still lots of work to be done in terms of real memory coming through things like sparse attention. I think as modalities increase, for example, we see context usage blow up with video, PDFs, etc. And it will require a lot of new innovation in sparse attention, for example, to be able to actually utilize these media-heavy modalities. I think there's still a lot of work to be done more on the people working at the lower level versus the builders when it comes to making memory more effective.
Before I come to Nikitha and ask you about the technical feasibility of those things, Ville, are you seeing any early use cases around persistent memory in your enterprise base?
It's kind of interesting, like with the question of like a branding, because I mean, it kind of boils down to context engineering. It's just like another thing that like goes there in the set of input tokens. I think like at the end of the day, it's a question of, I guess you referred like as well as state. And like, yes, these systems are like inherently stateful. I mean, the world is inherently stateful. I don't think that there's any question like whether that will be important. Now, whether it's a thing by itself, whether there's that this is the memory, this is how it always look like, I'm not sure. So I think that there will be different ways and different places like how that can be derived. But yeah, I think kind of in many different forms, I think that there will also like will be a lot of innovation in that space. But yeah, I think it's unquestionably going to be a big thing.
Nikitha, what are your thoughts on like the feasibility of this? Like not just the like enterprise need, but do you think as a product, as a technology, do you think it'll be feasible?
Yeah, I think the technology itself like more or less exists in that, you know, you're writing either to like memory or writing to disk, and we have that already. So I guess it's just a question of doing it in the context of large language models, which perhaps is the new part. So yeah, like saving application state, user state, persisting that across sessions. I think we're already seeing some providers show up. So technically, lots of cool stuff to be done, but it to me seems like an extension of technology that already exists versus something that's like 0 to 1.
Got it. And I think that's a good segue into kind of also talking a bit about, if you think of like a net new company needs to be created in inference optimization. We spoke about so many different topics, right? If I had to like break it down and into 4 categories, and maybe there are 5 categories. There's new model architectures where you're thinking of sparse attention, you're thinking of mixture of experts. That's one area where you could create a company. There's infrastructure and orchestration layers. So things around like hardware, software, co-design that we just spoke about, or like compilers, batching, all of that. Then there's adaptation companies. There's so many RL as a service companies. There's so many fine-tuning companies coming out there, which have an impact on the cost curve. And lastly, there is context and persistent memory. Now, it's yet to be seen if that falls in an existing adaptation technology or strategy, or it creates like a 4th category. If you were to like take a bet on like, this is a net new category and this is a net new area that should be interesting going forward from a startup point of view, which one would you bet on? Nikitha, what do you think?
Yeah, I've been paying a lot of attention to test time compute or test time inference. Basically, you add a bunch of compute at inference time to see what gains you can eke out. And there's a lot of interesting things, I think, that a lot of research papers mainly. So I would say this is not really productionized yet that I have seen. But kind of tailoring inference outputs based on user preferences in real time. So a bunch of this stuff, I think, is very speculative right now, but I think we'll start to see more of it showing up in products later this year, early next year.
Yeah, I guess since you ask about categories, I guess there's a question that is there some kind of a horizontal layer that could across many different applications? Maybe. I'm actually a really kind of unfortunately unpopular opinion, varies on focusing on just optimizations as a startup just by itself. I think it's a really appealing idea technically, but and I think companies who provide more a full stack are really well positioned to do that. I mean, just focusing on the low level optimizations as a startup might be difficult. Now I'm actually really interested in the idea of more and more companies also doing this a vertical integration of really kind of building the most excellent user product service experiences, even using the tools that are available today, but then innovating on their kind of own secret sauce, when it comes to the memory and maybe even the way how they use different kind of models and so forth, and really driving it kind of from the top down in that sense. I know that it won't be maybe a category by itself, but I would hope to see many companies doing the innovation kind of from that point
stack
of view.
Is more up to the application layer, or are you thinking
still all the way? I mean, imagine some kind of even a new consumer app, maybe a game. And even if today, if you want to do something that goes beyond what, I mean, because already in many ways, many of these AI things are becoming table stakes. And if you are generating kind of AI generating just images, what everybody has seen, I mean, it's kind of a bit meh today. But then the question is that how do you go beyond? And I still think that we are yet to see kind of this amazing mind-blowing, let's say, new games or consumer apps that really, because the building blocks are starting to be there. And it's just the way how you put everything together. And I think that then kind of pushing the limits what's possible, that's going to be exciting.
Makes sense. That's exciting. Yusuf, what do you think?
In the short to medium term, I would say, depending on the domain, excluding maybe coding or deep research, where I would expect frontier labs and to kind of really focus on with RL, verticalized RL in domains that are specialized, I think is going to get really interesting. Ideally, if things work well, models will generalize and this will be less and less of a thing, similar to what happened with fine-tuning. There, I think we might get back to things like memory and sparse attention as the next 10x unlock.
Sounds great. No, this is obviously a very exciting topic, and there's so many other questions that we can talk about, but fortunately out of time. So thank you so much for taking the time, and learned a lot from this conversation. And I'm sure people who are building in this space will approach each of you if they have any questions. Thank you so much.
Thank you.
Thank you.